Hello everyone. We are writing and evaluating expressions that have exponents today. Please make sure your name, date, and hour is in the top right of your paper. We have some vocabulary words today. We have a power, which is a product of repeated factors. We have the base of the power, which is the repeated factor that we are multiplying over and over. And then the exponent is the number of times that we multiply. It's the little number in the corner. Please remember at any point, if you need to pause to fill in or ask a question, you may do that. Here's a visual with our vocabulary words. So this whole expression, this is the power. We would read that as 3 to the 4th power. Here's some other examples. 3 to the 2nd power. We often say 3 squared. 3 to the 3rd power, also known as 3 cubed. 3 to the 4th power, and 3 to the 5th. The base here is 3. That's the number that we multiply over and over. The exponent is the little number. That's the 4. That tells us to multiply 4 times. This is not 3 times 4. That's a common misconception, but we write 3 4 times, and we multiply. 3 times 3, then take that product times 3, then take that product times 3. All right, so we're going to start by writing powers. So we're going to go ahead and write each product as a power. So here, my base is 7. Okay, and I see 7 5 times. Therefore, my exponent is 5. Go ahead and pause your video and try B and C. All right, so here we have 12 to the 3rd power. This one you should have put 100 to the 6th power. All right, the next thing we're going to do is actually find the value of powers. Okay, so here on the next page here, I have 7 squared, or 7 to the 2nd power. Remember, this is not 14. It's 7 times 7. And I am actually going to have you write that out. You're going to show me your process and what you're doing. So I'm going to write out 7 times 7. We've been talking about using this dot for multiplication. The reason being the x is commonly used as a variable when we get to algebra. So 7 times 7 using my algebraic dot. So I end up with 49. 7 times 7 is 49. There is a multiplication chart in your agenda should you need to use it at any point. Okay, letter B. Go ahead and try this one. Pause your video and give it a try. Okay, I wrote 5 out 3 times. 5 times 5 times 5, we end up with 125. Not 15 on that one. Okay, the next thing we're going to look at is just a perfect square. The square of a whole number is what we call a perfect square. I'm going to fill that vocabulary word here in my blanks. Here's a visual of a perfect square. When you first started multiplication, you probably used arrays as a visual model, just like this. 3 rows of 3 or 3 columns of 3. And if I was trying, I could show 3 rows of 2, 5 rows of 4. This is how we first learned multiplication. So what this is showing is if both are the same, it makes a square. So 3 squared is 9. I should have 9 little squares here. That's a perfect square. So when I have 1 squared, that's 1. 2 squared, that's 4. 3 squared, that's 9. 4 squared, that's 16. 5 squared, that's 25. These numbers, 1, 4, 9, 16, and 25, those are all perfect squares. I don't expect you to remember all the perfect squares or memorize them, but we do have to understand what it is and be able to explain if a number is a perfect square. For example, down here, 64. We're going to say yes, 64 is a perfect square. Okay? The reason being, I can take 8 times 8 or 8 squared and get to 64. So when I write out my explanation, I did that in a complete sentence, and I know we're in math, but complete sentences are important skills for all subjects. And then this just helps me justify my answer. I'm going to say yes, 64 is a perfect square because 8 squared is 64. You can say because 8 times 8 is 64, it would mean the same thing. All right, let's look at 20. We're going to look at 20. 20 is not a perfect square, so let's give an explanation as to why. So I said no, 20 is not a perfect square, and I use the explanation because no whole number squared is 20. If I look up here, 4 squared is 16, 5 squared is 25. There's nothing in between there I can multiply by itself to get to 20. All right, let's go ahead, turn to this last page, and if you would, please pause your video, and I would like you to work through problems 1, 2, and 3. Then you can unpause and check your work. Okay, here we go. 15 to the 4th, 6 to the 6th. For this one, I have 13 3 times. There's 13 to the 3rd power. I have 7 twice, times 7 squared. Go ahead and give yourself a rating here. Where do you think you fall on this? Just color that in. If you feel like you could teach this to somebody, you feel really good about it, that's a 4. If you can do it on your own, but you're not confident you could teach it, that's a 3. If you can do it with some guidance, a little bit of help from me, that's a 2. And if you don't understand this yet, go ahead and mark 1. Then you're going to pause your video and try the next 5. Number 4, I did 6 times 6 times 6 to get 216. Number 5, 9 times 9 to get 81. Number 6, 25 is a perfect square. 5 squared gets us to 25. Number 7, no whole number squared is 99. And on number 8, your friend says 20 is not a perfect square. We actually did this one together in our examples. 4 squared is 16, 5 squared is 25. The answer would be, we would agree with this person. We would say that's correct, or no, it's not a perfect square because no whole number squared is 20. We kind of skipped that in between here. Again, go ahead and give yourself a rating between the 1 and 4 where you fall here. All right, and there will be a writing frame posted for our summary. So our summary answers our question. If we were to say, how do you write and evaluate expressions involving exponents? We answer that question in 2 to 3 sentences. There will be a writing frame posted for you here as well.